So, significant figures are how uncertainty gets written into a measurement. So, significant figures is a way that scientists can sort of indicate the uncertainty of a measurement just by writing it down. So they don't have to explain how the measurement was taken or how good or bad the measurement is. It's sort of implied by the precision in how the number is written. So it's one way for scientists to indicate the quality of a measurement just by the measurement itself. It's not the only way, but honestly, as much as you will probably tell me you don't like significant figures, doing true error analysis and the statistical details is actually harder. So the idea is that a measured number is rounded off to the last measured place value. Remember, that uncertain digit is still a measurement, so that's the last measured place value. We're going to round it off there. If there are any non-measured digits after that, we're going to replace them with non-significant zeros. Okay, what does that all mean? Okay, let's talk about how in a number, if it's already written down by a scientist, how do we decide what is significant or measured and which ones are not? So first of all, the non-zero digits are always significant. That makes sense. Why would I write the number 3 in a measurement unless it was a measured 3? It's the zeros that are the troublemakers. Sometimes we use 0 in a number to indicate place. In other words, how do I indicate the difference between 20 and 2000? Well, the zeros are there for placeholders. They tell me the 2 is in the tens place or the 2 is in the thousands place. And so those zeros can be used as placeholders. But zeros can also be used as a measurement. If something is exactly on the line of a ruler and not a little bit past and not a little bit before, 0 can say, it's right here. There are 0 tenths or 0 100ths place. There's, precision to it. So sometimes they're measured zeros. So leading zeros, the zeros to the left of the non-zero digits, are always non-significant. They only can be used as placeholders. So therefore, any zeros that are to the left of where the non-zeros begin are not significant. Trailing zeros, that means zeros that come after a bunch of non-zero numbers at the end of the number, are sometimes significant. If a decimal point is shown somewhere, it doesn't have to be next to those trailing zeros. If there is a decimal point shown in the measurement at all, then trailing zeros are significant, all of them. If the trailing zeros, if there is no decimal point shown, like in the number 2000, 2000, and no decimal point, it is implied that those zeros are placeholder zeros, and therefore they are not significant. So if there is no decimal point shown, they're not significant. And then zeros in between, sandwiched in between non-zero digits, those are significant. I'm sort of indicating that I have in the number 207, the 2 is 2 hundreds and 0 tens and 7 ones. And so that 0 is a measured 0. Okay, so when we get to class, I'm going to have you practice this, but if you want to pause and take some time and practice, underline the significant 0. Again, I'm not worried about the non-zero numbers because they are significant, but if you want to underline them too, that's fine. And then in the second case, try to convert these numbers to scientific notation, or from scientific notation to standard notation. Remember, one of the things I didn't say though is that in scientific notation, all of the numbers, including zeros, that are shown with the prefix number in the scientific notation are significant. And so you have to make sure to show them if they are significant when you're writing into standard scientific notation, or identify them when they're coming in, going back into standard notation. All right, calculators. So I just want to point out a few things. Your calculator should have a exponential function, one that's designed specifically for scientific notation. On TI calculators, it tends to be an EE button, 2 capital E's next to each other. Casios tend to have an EXP button. And these are used to put a number into scientific notation. So it would be entered as 3.85 EE. You press that button, then that button takes the place of the multiply and the 10, and then you just put the exponent. So 3.85 EE, in this case I'll need the negative sign 7. Be also careful that your calculators will often have 2 kinds of negatives. One is the negative indicating the sign, and that's often in parentheses, or maybe it might be a plus minus key. And the other one is the operation subtract. And on a scientific calculator, you generally have two buttons, one for sign and one for the operation subtract. Make sure you use the right one at the right time. So in these cases, we'll be using the negative sign button. I do think you should put these in. One thing that happens is this is designed so that the calculator understands that this is all part of one number. This is not separate from this part number. And that's important, especially when we're doing division by a number in scientific notation. So some people say, oh, I don't want to learn the scientific notation button. I'm just going to use a multiply. I'm going to use the times button and then type in 10 and then use the exponent button and then put in the exponent. Well, that works sometimes, but not always. The problem is that this number and this number are considered two separate numbers by the calculator, and that will matter when we're doing divisions. You will get the wrong answer unless you put the entire thing in parentheses. By the time you do that, it's just as easy to learn how to use the exponential function, the scientific notation button on the calculator. Also, a lot of times the calculators exist in either scientific mode or float mode. So sometimes in scientific mode, it will convert every single number and display it in scientific notation. Sometimes when you're especially if you're doing financial things, you're like, that's kind of confusing to me. I'd rather have it in standard notation. Often that's called either float or normal mode. So you should get in the habit of learning how to convert your calculator back and forth. Sometimes it's nice to have it in scientific mode. Sometimes it's nice to be able to see it in standard. So here's some instructions on how to do it. Get your calculator, get its little manual out, figure out how to do it, and make yourself a little note card on how to do that. So the next step, once we can count, and we kind of talked about the calculators because where we're heading next is what happens when you do something with two different measurements. I'm going to do an operation. I'm going to add them, I'm going to subtract them, multiply them, divide them. How does that significance carry through? Well, the rules are if I'm adding and subtracting, the answer can only be as precise as my least precise measurement that I worked with. So I'm going to keep the same number of decimal places. So we're going by, remember, the precision in a measurement is determined by that place value. If I'm adding or subtracting, it's about place value. So I want to find the location of the uncertain digit and keep track of that. And that's where it's going to determine my rounding rules. If I'm multiplying and dividing, of course, multiplying and dividing makes numbers get bigger and smaller, and so place value is not as useful. Instead, I'm going to go by quantity of significant figures. How many significant figures does my least precise measurement, least precise measurement have? So I'm going to count the number of significant figures in all of my measurements in the operation, and then round it to the one with the fewest number of significant figures. Let's try some examples. Okay, adding and subtracting is actually more confusing for most people than multiplying and dividing. Again, we're going by place value. It does help to kind of know our mathematical place value numbers. So we talk about the tens place or the thousands place, and when they're to the right of the decimal point, we usually say the tenths place with a th at the end or the hundredth place. And so being able to use the mathematical term can be helpful. A lot of times if it's to the right of the decimal place, you just say the first decimal point place or the second decimal place. But if it's to the left, then I'm going to have to use things like tens place, hundreds place, thousands place. Okay, so let's start with 3.26 minus 1.26. When I look at the uncertain digit, in both cases, the uncertain digit is in the second decimal place or the hundredths place. So first I want to use my calculator and get the answer. That's what it's designed for. It can't do Sig Figs, but it can do the calculation. It gives me the number 12. However, the problem with that is that now when I've gone through and I've said, wait, this is significant to the second decimal place, and so is this one. Why isn't my answer? It should be as significant as my least significant measurement. So I'm going to have to add in some zeros. So in this case, I need to round it to the second decimal place. Well, the fact that there is nothing there means I'm going to have to add in some placeholder zeros, some significant zeros. These are now measured zeros because I measured the tenths place and I measured the hundredths place. So these are measured zeros and therefore they're significant. Another answer, another problem, 251.3 plus 790. I get 1041.3 on my calculator. Now remember, the 3 is my most uncertain digit. This is my uncertain digit in the first one. That's in the first decimal place. But in 790, this 0 is not measured. I know that because it's not significant, and it's not significant because it's a trailing 0 with no decimal point shown. So this is only significant to the tens place. Again, this is where I'm going to use that mathematical notation of this is the tens place. So I want to round my answer to the tens place. I'm going to underline the tens place just to make it easier to sort of see. So in this case, I look at the next number. It's a 1. 1 is not 5 or greater, so I'm going to leave this, I don't round it up. So it's just going to go to 1040. Note that I have to keep the place value, so I'm going to replace the 1 with a non-significant 0. And I indicate it's non-significant by not putting a decimal point there. Last one, 145.675 minus 24.2. My calculator says 121.475. Okay, again, now I go back and I look. This number is significant to the first decimal place. This one is significant to the third. This is the least precise measurement. I'm going to round my answer to the tenths place or to the first decimal point. And that becomes 121.5. Remember, we do look at the next digit. If it's 5 or higher, we're going to round this up, and that's what we did in this case. So that's what it looks like for adding and subtracting. I could also write these in scientific notation. That works as well. This ends up being more helpful when I'm doing multiplying and dividing, but it's still useful. Remember, I can use that E to indicate the size of the number. Multiplying and dividing, I'm going by the quantity of sig figs. I'm going to round to the same quantity of sig figs as the measurement with the fewest quantity of sig figs. No longer the decimal place value, but the quantity. So 481 times 185, I start with my calculator, I get 7585. I go back to my number and I want to find which one has the fewest number of decimal significant figures. 41 has 2 and 185 has 3. So 41 has the fewest, 2 sig figs. I need to round 7585 to 2 sig figs. I begin with the leftmost non-zero digit. That's the 7. It's also the first digit. And that's going to be the first one. The 5 will be my second one. I'm looking at the 8 to determine whether I round up or not. And in this case, since it is bigger than 5 or bigger, I'm going to round up. So this becomes a 7 and a 6. Those are my 2 significant digits. I replace the 8 and the 5 with zeros. I could also write it as 7.6E3. Note that because there are 2 digits over here, it's pretty clear to see that this is a 2 sig fig answer. If I put 2.40 over 125 times 0.42, remember, be careful. When you enter this in your calculator, do not do 2.40 divide by 125 times 0.42. When I use my operations on my calculator, it's based off of the first number that was entered. 2.4 is actually being divided by 0.42. Another answer is that I could multiply these two together first, either putting them in parentheses in one answer, or I could come up with an answer, write it all down, and then do a second calculation. But I like to do 2.40 divide by 125 divide by 0.42 because 2.4 is being divided by 0.42. Either way, my answer is 0.0457. So I go back to the first number. This number has 3. Remember, this is a significant 0. 3. This number has 2. Leading zeros are not significant, so this is 1, 2. That's going to determine how many significant figures my answer can have. I'm going to start with the first non-zero number. Remember, these are non-significant. They're leading zeros. So I go from the left until I get to the first non-zero number. That's going to be my first sig fig. And then 5 will be my next sig fig. I look at the next number. It's 7, so I'm going to round 5 up to 6. I could also put it in E notation. Last number. So calculating this, I get 0.005543. If I look here, this number has 1, 2, 3. That's non-significant. This number has 1, 2, 3. These are significant. This number has 3. This number has 2. So I'm going to use the 2 sig figs to round this properly. Okay, so again, I'm going to go to my first non-zero digit, and that's going to be my first one, and then the next one's 5 is the second, 5 is going to be my second one. I look at the next number, it's 4, so I'm not going to round up. 0.055 is my final answer. Another thing that just gets tricky here is exact numbers. Exact numbers are not measurements, and so therefore we don't talk about them having any significance. Or they have infinite significance, I would say. So when we look at them, we're going to ignore them for rounding purposes. So when I'm looking at all my numbers to see which one has the fewest significant figures or which one has the least precise decimal place value, I'm going to ignore the exact numbers. They're considered to have infinite precision. There are two kinds of exact numbers. One, things that are counted. Things that are counted can't be in between. So if I'm counting balls, tennis balls, I either have 3 tennis balls or 4 tennis balls. You can't have 3.2 or 3.01. It's exactly 3 or exactly 4. The other kinds of exact numbers are things that are defined. So when I say 1 quart relative to 4 cups, I'm defining that 1 quart is exactly equal to 4 cups exactly. So it's a defined relationship, or 1 foot is equal to 12 inches exactly. Whereas I have some measured equalities. So I have 2 different kinds of measurements, and I want to weigh out, well, what is 1 pound in kilograms? Pounds and kilograms were not defined relative to each other. So I can take a kilogram, in this case I take a kilogram because it happens to be the bigger weight, and I'd weigh it on a scale that weighs pounds, and the number I get will be determined by the precision of my scale. It might be 2.2, might be 2.21, it might be 2.205. So where I round that number is actually, that is a measurement, and so that one does have significance. So one of the tests would be, try to add an extra decimal place of a 1 and see, does this make any sense? So when I say 12 inches equals 1 foot, the question is, could it be 12.1 inches equals 1 foot? No, that doesn't make any sense, right? It's exactly 12 inches. So that means the 12 is considered an exact number, so is the 1 in the 1 foot. When I talk about 1 kilogram equals 2.21 pounds, or 2.2 pounds is often how it's said, the 1 is considered to be exact. I begin with an exactly 1 kilogram. I put it on a scale and I measure it. This 2.21 is a measurement. That's going to have significance. So this has 3 significant figures. I might, so I say, is it possible that instead of 2.2, it's 2.21? Maybe. Or instead of 2.21, it's 2.216? Maybe. So if it can go on more decimal places, and I think that that could be reasonable of an answer, it doesn't mean I have to know that that's the answer. Is that a reasonable thing? Then that's going to be a measurement. Note that one thing that's a little tricky is that 1 inch equals 2.54 centimeters. That actually is a defined measurement. That is a defined value. It is not a measurement. It is a defined relationship between the metric and the British system that they set up. So a couple of tricks for dealing with sig figs. If you're adding or subtracting numbers, it's really helpful to underline the last significant place value of each measurement, especially because you rarely have them written down vertically. You often have them written horizontally. So it's much easier to sort of underline them and help keep track of where they are in the place value. If you are rounding to a specific place value, either way, whether you're doing it sig figs, counting sig figs, my final answer, I need to round it to 2 sig figs, or I need to round it to the 10th place, underline the position that you're trying to round to. That helps you sort of clarify. I want to keep it to this number, but I want to look at the next value. When rounding to quantity, and I'm trying to count how many sig figs before I round it, kind of start from the left and go along until you get to the first number that's a non-zero number. That's going to be very helpful. And then I continue on until I have the right number of significance, and then I underline that last significant digit, and then I decide about rounding. And when I'm considering if something is exact or not, in other words, if it's exact, I can ignore it for purposes of rounding, try to decide which one which is the least precise measurement, I'm going to ignore the exact numbers, and I want to kind of ask, could it be, I add an extra 1 at the end of it and say, is that plausible? If it's plausible, then it's probably a measurement. If it's not plausible, it's likely it's a defined exact measurement, or not a measurement, an exact definition. So in class, we're going to practice this. So here's your practice problem. It is a problem where you have to calculate an answer and round it properly. So you'll need to practice all of these skills.